And thank you so much for having me here today. What I want to talk about today is actually the findings of two papers that have a common theme, and that is how to close race and income-based gaps in achievement, especially among students who have high ability or high potential for achievement. Both of these papers are joint work with David Card, and both are part of a evaluation of a broader set of policies that were implemented by a large urban school district. These policies were all aimed at expanding participation in gifted programs in particular, and closing the achievement gap. So motivating facts. So in the US, if I expand this, is it going to freeze again? It might. I took the risk anyway. Okay. About 7.5% of white students have participated in a gifted education program, according to data from the Department of Education, but only about 4.5% of Hispanics, less than 4% of black students, and less than 2% of English language learners. So why is this? Well, we know from work like Sean's work that there are big race gaps both across and within districts, and that things like observed measures of segregation and schooling quality can't explain all of these gaps. Data from the Department of Education Civil Rights Office also suggests that there are big gaps within schools. So Black and Hispanic students make up about 40% of students that are in schools that offer gifted education programs and AP courses, but they only make up about 30% of students actually enrolled in these courses or programs. There's also there's a lot of research actually looking at the causes or the possible reasons for underrepresentation in gifted programs. There's a long literature in the gifted education literature, but there's not a lot that's looking at large nationally represented data sets. One recent paper looks at the ECLS, and sort of in the tradition of work by Tom, looks at the effect of having a similar teacher and finds that black students are more likely to be referred for a gifted program if they have a black teacher. And then finally, we know that test score gaps are present when students enter school, and they tend to grow, if anything, over time. And there's some evidence that this is especially true for kids at the top of the distribution. So all this suggests that, we might want to know whether this achievement gap is partly explained by the failure to identify high ability students who are from disadvantaged groups and also to serve these students. The first of which is that to qualify as gifted in the state of Florida, you have to achieve a certain IQ threshold, and that's the main criteria. So the traditional threshold is an IQ of 130, 2 standard deviations above the mean. But for a long time, the state has encouraged districts to adopt what's known as Plan B in the law to find ways to expand participation for disadvantaged and underrepresented groups. So historically, this was based on race. Up until 2003, this was based on race. In 2003, they changed the rules, so it's now to qualify as Plan B eligible, you need to either qualify for the free lunch program or be an English language learner. But so the rules are that the districts can create their own Plan Bs, including using lower cutoffs for the IQ. And the district that we study does this. This is one of a few things that they do to try to expand participation in the gifted program. They set the IQ cutoff for Plan B students at 116. I know this is sort of an unfortunate terminology, Plan B, but that's what they call it, so that's what I'm going to use. So even though, for a while they've had this lower cutoff for disadvantaged students, but even with the lower cutoff, Black students, Hispanics, low-income students who are still significantly underrepresented, I'll show you in the gifted program. So what they did in 2005 is introduce a couple of new programs to try to expand access. And one hypothesis for why the underrepresentation continued despite the lower IQ cutoff is that students weren't referred for IQ testing in the first place. So you actually have to go have an IQ test with a psychologist, and this requires a referral. So students were just not being referred. So in 2005, they introduced a universal screening process that was the first thing we're going to evaluate, and I'll describe that to you. The other thing they did was to change or expand a particular model for serving gifted students, and mandated that in all schools, in 4th and 5th grades, all schools were required to use a separate classroom. So if there was at least one gifted student in a school grade cohort, they were required to set up a separate classroom for gifted students. Now, in most schools, in most elementary schools, there are only a few gifted students. So what they decided to do is, and effectively this expanded access to the program and to these classrooms, was to allocate the extra seats in the classroom to other non-gifted students, and they did this by ranking them on their prior achievement scores. So this created an effective tracking program for high-achieving students, and this was really effectively a tracking program in a lot of low-income schools where there were only a couple of gifted students. So we're going to evaluate this program as well. So 3 things we evaluate: the impact of the universal screening program. As part of our broader project, we've done evaluations of both the effect of being identified as gifted, which requires an IQ cutoff, and the effect of being enrolled in one of these gifted/high achieving classes, which I'm going to refer to as a GHA class. And in both cases, it's rule-based, eligibility is rule-based. So we've used an RD to evaluate both of these programs. I'll just mention the results quickly from the first one, where I'm going to focus today on our evaluation of the impact of being placed in a high achiever classroom. So we use an RD method based on the cutoffs for being placed in the classroom. And then to look at the impact of being in a classroom, we also use a between-school design that allows us to look at the impact of these classrooms on students who don't get in. So one of the issues with an RD design is you're comparing students who just make the cutoff to those who just miss the cutoff, and those who just miss the cutoff don't necessarily provide the right counterfactual for the absence of the program. So we use 2 designs both to confirm the RD results and to look at potential spillover effects. And then finally, we look at heterogeneous effects by race, ethnicity, income, and gender. So I'll preview the main findings from all the studies, just in case I don't get through it. The universal screening program, we find it substantially increased the representation of Black, Hispanic, low-income students, and especially English language learners. Among the Plan B eligible students, the free lunch eligible and the English language learners, the likelihood of being identified as gifted rose by 170%. So this is a very large effect on gifted eligibility. Now, in our evaluation of the impact of being identified as gifted, we actually didn't find significant effects for the marginal student who is identified as gifted. So this is for being gifted as opposed to just being placed in the gifted classroom. We found small positive effects on writing achievement for the Plan B students, but we didn't find any effects on math and reading scores for those marginal students. And it's an interesting question why. It's something, again, I'm not going to spend a lot of time on it today, but we can, if I come back at the end of the talk, we talk about mechanisms. Be interested to hear your thoughts. One of probably the most interesting results that came out of this RD evaluation was the fact that there's a huge amount of manipulation in IQ scores. And this is one of the challenges actually we faced in the RD design. We spent a lot of time trying to get around it still to find that there were no impacts, but it was actually quite interesting. I'll show you some evidence that psychologists really manipulate IQ scores. So then finally, we look at the impact of participating in a GHA classroom in 4th grade for the non-gifted high achievers who get into the classroom on the basis of their achievement scores in 3rd grade. And here we find positive effects on average effect sizes of about 0.2, 0.3 standard deviations. We find that the effects persist to 6th grade. We find when we do the heterogeneity analysis that they're concentrated among minorities, among Black and Hispanic students. So I'm going to refer to Black and Hispanic students as minorities. There are a small number of Asians in this district, so it's hard to analyze them separately. But these effects are about half a standard deviation. And as I'll show you, they're large enough to close what I call the underachievement gap. So for students with the same level of measured cognitive ability, there's actually there's a gap in achievement conditional on cognitive ability, and this is large enough to close that gap. We find that these effects are consistent across both of our research designs, and using the between-school cohort design, we don't find any evidence that there's a spillover effect on students who are left in the regular classroom. So in principle, that spillover effect could be either positive or negative, but we don't find that the other students are really affected at all. So the net effect is a positive effect for minority students who are in the classroom, the marginal students. So the outline of my talk today, I'll start with the impact of the universal screening program and really just give you an overview of the program and the key findings. And then I want to spend most of the time on the evaluation of the Gifted High Achiever or tracking program, which we're going to call a tracking program. I'll go through an overview of the program, talk about the results, the two different research designs, and save potential mechanisms for the end because that's where we have the least evidence, but that's also probably the most interesting and most important question. So if I'm running out of time, I'll try to make sure I leave time to get to that. Speaking of which, is there a clock in here? Anyway, make sure if I start to run out of time, someone can yell at me. So the process for gifted screening and identification in the district, there's really two steps to get into the gifted program. First, students have to be referred for a full evaluation, and then they receive an evaluation which is mainly this IQ test that they have to take, which is with a sort of one-on-one full IQ test with a psychologist. The first step of referrals prior to 2005 was largely based on teacher and parent referrals. It depended heavily on teachers and parents. So it was actually a pretty non-transparent system, but it required, among other things, nomination forms to be filled out by teachers and either by parents or a member of the community. So it really required both. Even to get to the referral process, the teacher had to say, oh, I think this student needs to be screened, and then they would collect all the data. So it relied heavily on teachers to recognize that a student might be potentially gifted and refer them. Beginning in 2005, the district started using universal screening, and I'll tell you more about the details of this program in a second. Once a student's referred, then they can receive a free IQ test by a school psychologist in the district. So that's not really constrained. They're put in a queue for a free IQ test, but they're also allowed to go get an IQ test with a private psychologist. So if parents have money, these private IQ tests cost somewhere between $500 and $1,000. They can go to a private psychologist, report the scores back to the district. Then the final determination of gifted eligibility is based, again, largely on the IQ scores with the cutoff of 130. If you're not disadvantaged, or 116 for the free lunch eligible and English language learners, the Plan B students. For this group, it's all about the IQ score. Pretty much everyone who has an IQ of 130 or above gets in. For the other group, there are some other things. The characteristics, the gifted characteristics checklist is really supposed to be satisfied by all, but it's sort of almost always satisfied for the high IQ kids. And then they have to say that there's a need for a special program. So there's some discretion there. The screening program that started in 2005. So they do the screening in second grade, and the idea is that they want to get most students into the program beginning in third grade, although the full-blown gifted high achiever classrooms don't start till fourth grade. They screen them in the spring of second grade. They use the Naglieri Nonverbal Ability Test, the NNAT, which is like the Raven's Matrix, is picture-based, as the name suggests, so it's supposed to be culturally unbiased. They administer it in the classroom to everybody. And then they take the scores on this test, they rescale them based on age and the raw score, so that they create a nonverbal ability index that's scaled similar to an IQ test. Then they use cutoffs on these scores to determine who is automatically eligible for a full evaluation. And so the key difference between the new screening program and the old is, well, first, it's universal, and second, referrals are automatic based on these cutoffs, so they're no longer rely on teacher and parent referrals. The cutoffs that they use are similar to the cutoffs for gifted eligibility on the IQ scores, and nonverbal ability index of 130 or above for non-disadvantaged students and 115 or above for Plan B students. Also, importantly, they did not change the eligibility criteria for being gifted. So the IQ cutoffs for actually becoming identified as gifted were the same, and the other requirements remained the same. Now, the program in this form was in effect between 2005 and 2009, but it was really most effective in the first 2 years. In the first 2 years we studied, and this is because it actually was fairly expensive. The main expense was not the screening test, but the IQ test. So they were testing a lot more students, and each test takes about 2 hours with a school psychologist. In 2007, with the recession, there were big budget cuts. And so the program was scaled back a bit beginning in 2007. It was eventually suspended. It's back. They have a program now, but they use a different instrument. So we're really just going to focus on the effect of the program fully implemented in the first couple of years. And here's the time series pattern of the fraction gifted in the district by the end of third grade. So these are the 2 pre-treatment years. We start in 2004 because the rules, the Plan B rules, were really interested in the impact not just on the overall participation rate, but on the differential participation rate for minorities. And since the Plan B eligibility rules changed in 2004, we just start in 2004. You can see that there's a big jump in the fraction of students who are identified as gifted by the end of third grade. It goes up from about 3.5% to about 5.5% on average. So I think this is pretty clear that there's an effect, but we might want to think about what's the counterfactual trend. We used data from publicly available data from at the school level from other schools in other districts in the state. One other district in the state also implemented a universal screening program, so we don't use that district, but all the other districts we used to construct a comparison group, and we used propensity score weighting to construct this group using things like the initial level, the initial fraction gifted, and trends in the fraction free lunch, in the fraction minority, and in the enrollment numbers. So in the first couple of years, we've matched pretty well to this comparison group of schools. And you can see in the rest of the state, gifted rates were trending up only very slightly initially. And then there were some other things going on. The gifted rates were actually trending up in the later years in comparison schools, whereas in the district, they fell when there were budget cuts. And in the year that the program was suspended, they came right back to where they were to begin with. So this really suggests to us that it had something to do with the program itself. It wasn't that suddenly everybody became aware that there was a gifted program and the teachers started referring kids. So here are some characteristics of the third grade students in the district from the student level data. So most of what we do is once we sort of established this comparison using school level data from the district and other comparison districts, we go to the student level data from the district, and we're going to do some pre and post simple comparisons. But just to give you a sense of what the students in the district look like, it's very diverse. It's about a third white, a third black, a third Hispanic, relatively few Asians. About half of the students qualified for a free lunch. About 1/10 of them were English language learners in third grade. So Plan B eligibility is based on free lunch and English language learner status. Roughly half of the district was Plan B. A lot of them had parents who didn't speak English as their primary language. Then we can see there are big differences as you'd expect between the Plan A's and the Plan B students. Down here we have, I guess the other thing we looked at is whether there were big changes in the composition of students over time. And over time, there is a slight downward trend in the fraction white. So we can estimate models that are adjust for a trend to account for that. But for the most part, the characteristics are pretty similar pre and post. The fraction who are tested with an IQ test jumps a lot in the post period. So the gifted rate went up, but also the fraction who are got an IQ test went up, and the fraction of students with an IQ score above the gifted threshold went up significantly. Now, we're really interested in how this affected the diversity of the program. It was intended to expand participation among the disadvantaged groups, and that is what it did. If we compare the trends for Plan A versus Plan B eligible students, we see that the big jump here was among the Plan B eligibles, though there is a slight increase, but more of a trend among the Plan As. So we can also look by race and ethnicity, and this is highly correlated with free lunch status in our districts, so it looks sort of as you'd expect. There's some low-income whites that were affected. The biggest increase was among Hispanic students, and there's also a large proportional increase for Black students. We estimate these changes. We use both the difference in difference approach using the school level data with the comparison group and just a simple pre-post event study approach using the district data only. If we adjust for a trend, we get very similar estimates in both cases. So we find a 1.5 percentage point increase in the fraction of students who are identified as gifted among all students. But then when we break it down, we find that the effects were concentrated largely among the Plan B eligible students, among Blacks and Hispanics. And it's most useful to translate these into proportional increases. So these are from the Logit model. Among Plan B students, the increase was 170%. It was all negligible for Plan A eligible students, and for whites, big increases, a 74% increase in the likelihood of being identified as gifted for Black students, and an even larger increase for Hispanic students. Although, statistically, Blacks and Hispanics are similar, and they're different from whites. So another way of looking at the effect on the gifted population is to ask, what are the characteristics of the compliers with this program, the students who are identified as gifted who wouldn't have been in the absence of the screening program? So this here shows the characteristics, the mean characteristics of all gifted students before the screening program, after the screening program. The compliers, which the students who are identified before the screening program we can think of in the terminology of a randomization with incomplete compliance as the always takers, right? They were going to be identified regardless of the screening methodology. The students in the post cohorts are a combination of always takers and compliers, those who wouldn't have been identified otherwise. So their characteristics are a weighted average of the always takers and compliers. So we can back out the characteristics of the compliers and then ask to what extent did the program disproportionately affect some groups versus others. So we can see that it disproportionately affected Plan B eligible students. Among always takers, only about 20% of Plan B students were going to be identified regardless, whereas 80% of the compliers were Plan B eligible. There were also disproportionately non-white. Again, this is just another way of looking at the data. Disproportionately female, although this isn't a large effect. We find the program had bigger effects for girls, bigger effects for free lunch eligible students, English language learners, students whose parents did not speak English. And it really expanded the program into schools that had large fractions of students who qualified for free lunches and high minority schools. Now, if we look at the average IQ and achievement scores, we see that on the whole, the program identified students who had relatively low IQ scores. But this is to be expected. This is mechanical, really, because it identified a lot more Plan B students, and the cutoff was lower for Plan B students. So if we look within the Plan B eligible students and ask, what happened to the average IQ score of students who ended up being in the gifted program? We actually see that there was no change. So the mean IQ of the compliers was virtually the same as the mean IQ of the always takers among Plan Bs, who all face the same cutoff. However, we also see that those who got in had slightly lower achievement scores. All right, so I'll come back to that point that might sort of suggest why these students weren't recognized in the first place and that they were in some sense underachieving relative to their potential. It's also interesting, though, to look at the distribution of IQ scores before and after. So here we're just comparing again the always takers and the compliers among the Plan B group. And we can see, so the cutoff is 116 right here. We can see that if anything, the compliers were less likely to have scores right near the cutoff and more likely to be higher IQ kids. So there were plenty of students who were significantly above the cutoff who were being overlooked under the traditional screening mechanism. Another way of looking at this is to look at the full distribution of IQ scores before and after the screening program. The green here is pre-screening, and the orange dotted line is post-screening. So if we look at Plan A, first of all, one thing that really pops out is this big spike at 130 and this notable absence of any high-income students who have IQs of between 125 and 129. And so this is partly reflective of the option for private testing, but we've collected data on, we've had to do by hand, go in and take a random sample of students and see who is whose IQ scores came from a private psychologist, and even among the school psychologists, there's a significant amount of manipulation. If we look at, but we can also see that sort of the increase in IQ testing was fairly well targeted. There wasn't an increase in testing among students who were sort of down here at the bottom of the distribution. So a lot of students were IQ tested for reasons other than gifted, for learning disabilities. If we look at the Plan B, the plan group here, we see that most of the increase came from the top of the distribution here. And importantly, it did not take resources away from those who were being tested for other reasons, for learning disabilities. Another, I think, especially dramatic way of looking at these distributions is to overlay the Plan A versus Plan B IQ score distribution. So if you were to take the IQ scores, look at the distributions before the universal screening program, and compare Plan A versus Plan B students, you think, wow, there is a huge difference in the distribution of IQ scores between these two groups. It's more than standard deviation. But if you look after the screening program, there's still a difference, but they're much closer. So this was largely due to selection of who was IQ tested. Essentially, Plan B eligible students were mostly referred for IQ testing for learning disabilities, and that didn't change, but many more of them were referred. Many more from the top of the distribution were referred after the screening program. And now the difference is about 0.7 standard deviations. So the screening program also significantly expanded participation to low-income schools. This graph shows like a Lawrence curve sort of with the cumulative share of all students on this axis, cumulative share of gifted students on the vertical axis. We can see before universal screening, the gifted students were concentrated in a relatively small number of schools, and the fact that this line gets closer to the 45-degree line after universal screening suggests that there's more even distribution across schools, although not perfectly equitable across schools after universal screening. So, in fact, one of the main effects of the screening program was to establish gifted programs, essentially, in many more schools. And that sort of leads us to the next evaluation that we do, to ask what happens now that a lot of these schools that didn't have any students identified as gifted before the screening program now have at least one student identified as gifted, and now they have the opportunity to establish a gifted high achiever classroom. And that affects a lot more students than just the students who are identified as gifted. So just to wrap up, the conclusions of this first analysis are that without any change in the standards for gifted eligibility, the screening program led to a large overall increase in the fraction of students classified as gifted. a much greater diversity in the gifted population, a substantial equalization, not full equalization in gifted rates across schools. And then the second key takeaway is that compared to the students who are identified under the traditional system, the newly identified students had similar IQ scores on average, but they had lower achievement scores. And one explanation for this, or one thing that this suggests, is that the teachers and possibly also the parents were failing to recognize the potential of some of these students that had high IQ scores, but they had less than stellar achievement. Not terrible, but not off the charts achievement. And therefore, they were not referred for the gifted program in the first place. Okay, so what happens then when we have many more schools that have at least one gifted student by the time they're in 4th grade? And the district has also set up this system where they create gifted high achiever classrooms whenever there's at least one student in the school. Well, as I said, this effectively creates a within-school tracking program at most schools. And why is this? Well, most schools before the screening program didn't have any gifted students. Even afterward, most of them have less than 5 gifted students. The GHA classrooms are required to be roughly the same size. There's class size law in Florida that was being implemented during this time, so class size was being gradually reduced. But on average, the class sizes were 20 to 24 students over this period. So the extra seats in the classroom were filled by the non-gifted students with the highest test scores in the previous years. And the district refers to these students as high achievers. So I'm going to refer to them as high achievers. And it's like a tracking program because the classroom peers have higher baseline achievement since they're ranked on their achievement when determining who gets placed in the GHA classrooms among non-gifted students. So just looking at, so we evaluate this program using 4 cohorts of 4th graders. We have about 140 schools, elementary schools in the district. So this is based on over 500 school cohort observations. And what we want to show here is just sort of first the distribution of the number of gifted students in each classroom across schools, and also the composition of the gifted classrooms across schools. So on the horizontal axis here, we have the number of gifted students in the school cohort, and this is among 4th graders. And the dark black line here shows the frequency distribution. So we can see that most schools in the district had 5 gifted students or less. About 12% of them had no gifted students. So we're going to use those schools as the counterfactual when we do the between school analysis to ask what's the impact of having a GHA classroom in the school. And then the other thing we see is, so these dotted lines here are the fraction of gifted minority and white students in the GHA classrooms across different types of schools. And what we see is gifted students make up a relatively small share of these classrooms. In the typical school, there are 1 or 2 white gifted students, 1 or 2 minority gifted students. This line here is the fraction of white high achievers. So across all schools, the classroom has between 20 and 30 white high achieving students. And by far the largest group is minority high achievers. So this is this line here. And this is especially true in these schools that have relatively few gifted students. So they're the ones that we end up finding large effects for. So how are these classrooms different from the regular classroom? And here I'll say that first of all, it varies a lot. We don't know exactly what each teacher is doing and how they differ. But what we do know is they don't differ in terms of the required curriculum. They don't differ in terms of the textbooks that they're given. The teachers are encouraged to move at a faster pace and to supplement the curriculum with enrichment activities or go deeper into the curriculum. Another difference is that the teachers in these GHA classrooms, because they must be gifted endorsed in order to teach gifted students, these classrooms all, for the most part, unless the school gets a waiver, have gifted endorsed teachers. Gifted endorsement in the state of Florida requires 5 courses that are the same required by the state, One of these courses, interestingly, focuses on educating special populations of gifted students. So we don't know how much this plays a role, but it's potentially, this is part of the explanation for why we find benefits for minority students. The gifted students, but not the high achievers, are required to have individual education plans, and they have some goals for differentiated instruction. Now, we've looked at some of these, and it's just really not clear. Some of them are very vague. Some of them say, oh, the student is good at, likes to read, so they're going to read an extra book and write a book report, but it really varies. And so to try to get at what's really going on in these classrooms, we did some interviews with 30 teachers who had experience teaching in both types of settings, both the GHA classrooms and regular classrooms. And what they said for the most part, they all said that they tend in the classroom to use ability grouping, and for the most part, high achievers and gifted students are getting the same thing, with the exception of any special projects that the gifted students are doing. But for basic curriculum instruction, they're using ability grouping where they're grouping both gifted and high achiever students together, and covering the basic curriculum, perhaps at a faster pace than in the regular classroom. Most of them said they do less drill and kill than in the regular classroom, and that they supplement the curriculum with enrichment projects. So a few details on how students are placed in the non-gifted, in the GHA classrooms. So among non-gifted students, they're ranked using the previous year's test scores. So for the 4th grade classroom, they're ranked using their 3rd grade scores. Each school is going to have a separate cutoff. And so the cutoff, if there are 5 gifted students and the class size is 20, there are going to be 15 spaces for non-gifted high achievers. So the nth ranked student, the 15th ranked student, based on the previous year's test scores, is that score is going to be the cutoff. In practice, we have to estimate these cutoffs because there's some measurement error in the rosters, but that's our, where we start when estimating the cutoff. Fortunately, there is a district-wide formula for ranking students. Actually, before 2009, schools could kind of do what they wanted, but then in 2009, the district decided that all the schools were going to use the same formula, so we know the formula for ranking students. It's some combination of the scale scores on reading and math. So it's highly correlated with the average score in reading and math. It's not exactly, it's sort of a lexicographic formula where they use the achievement levels, and then within each achievement level, they rank students on the average scale score. But essentially, it's based on the standardized achievement tests in reading and math in 3rd grade, or the FCAT. So we're going to use that district-based ranking formula and the scores from 3rd grade as the running variable in the regression discontinuity design. So it'll be based on within school rank, and we'll have a separate, yeah, Sean. Mm-hmm.
Just curious, how correlated is the running variable constructed from the test scores with their
Oh, yeah, that's a good question. They are, I think it's around 0.7, but it's not. It's correlated, but not perfectly. I'll show you. We can look at sort of to test the validity of the RD. I'll show you the relationship between the NNet score and the baselines and the running variable. Yeah. So the one thing about these cohorts, these are later cohorts, the 2009 to 2012. So there are some students in here that were potentially gifted. They just didn't get referred and they didn't get IQ tested. But on average, they're slightly below the IQ cutoff for gifted eligibility. So there's a combination of students who just didn't get referred and students who wouldn't made the cutoff. Yeah. Oh, yes. There's quite a bit across schools. There's quite a bit of variability. And so we're going to do some cuts for different schools based on the number of gifted kids in the classroom. we'll do some cuts by free lunch status, which is highly correlated with where you go to school. In the end, most of our results are driven by minority students who attend the relatively low achieving schools. And so these marginal students, if you rank them against well, I'll show you the data, but if you rank them against the entire district, they don't appear to be, they're not in the top 5%, they're not what you think of as a typical gifted student, but they're high achieving within their schools, right? So one disadvantage of the RD design is that, again, if there are spillover effects onto the students who are left in the regular classroom, then it's hard to interpret the differential effect between the students who just make the cutoff and those who just miss the cutoff. So to address that, we use the fact that a school can only have a GHA classroom if they have at least one gifted student. And we're going to use this between school cohort design based on basically instrumenting for being in a gifted classroom with having a gifted peer in your school cohort. So we're comparing students in school cohorts that have a GHA classroom and don't. And then we can do this comparison for students who are at different rank levels. We do it for the top 20 students who should be in the classroom if there is one, and then also look at the effects for lower ranked students to see if there's any positive or negative spillover on them. So the sample for all this is we have 140 non-charter elementary schools. We exclude the charter schools. We have 4 cohorts of fourth graders who are entering fourth grade in between 2009 and 2012. And we look at these years because these are the years for which we know the district ranking formula. The RD sample, we use students whose rank is plus or minus 10 from the school-specific threshold, which differs across schools. And we do some robustness tests there. So we're using administrative student-level records. We do have the NNAT scores from the screening test for all but one of these cohorts because there was one year when they suspended the program. We have the standardized scores in reading and math for grades 3 through 6, for writing in 4th grade, for science in 5th grade, and then we also look at attendance and suspensions. So I already talked about the characteristics of the district in the earlier years. In the later years, there were some demographic trends. There are more blacks in the later years, slightly fewer whites, but it's still a pretty diverse group. Significantly more students qualify for the free lunch program and therefore for the lower Plan B cutoff. And this is not surprising since it covers some of the recession years. We still have about 10% English language learners. The average NNAT score in our RD sample, which is plus or minus 10 from the cutoff, is right, like I was saying, right about 113, which is right near the gifted eligibility cutoff if you were to translate this into an IQ score. So this is our full RD sample. We split the RD sample by schools with 5 or more gifted and schools with 1 to 4 gifted. And we do this because we want to use this between school design, but for the between school design, just to avoid comparing schools with no gifted students to the schools that have, like 2 classrooms full, there are a couple students that are like everybody's gifted, right? So we want to exclude those and just focus on this lower half of schools where we just have between 0 and 4 gifted students. And as you'd expect, this sample is there are fewer whites, more blacks, more Hispanics, more free lunch eligible students. So we'll start by going through the RD design and results. This is the distribution of the running variable. It's close to uniform, as you might expect, because these are just ranks within school ranks. So it's hard to imagine how a student or teacher would manipulate their score around this school-specific cutoff, which isn't really even determined until they start placing kids in 4th grade. So that's reassuring. Now, the other way we can look at internal validity of the design is to look at how the predetermined characteristics vary through the cutoff. The baseline reading scores look very smooth through the cutoff. Baseline, this is 3rd grade. Math scores smooth through the cutoff. Here's the nonverbal ability index. Again, we don't see any evidence of a discontinuity there. And it's positively correlated, but especially at the upper end, not extremely highly correlated, and that's because there's this top out on the NNAT. And then we also have predicted fourth grade reading and math scores, where these are predicted from a model that uses baseline scores and student characteristics. And again, this is very smooth through the cutoff, suggesting that we've got a valid design. This is the first stage relationship between the relative rank and the probability of being placed in a GHA classroom. So we have a fuzzy RD design, and the discontinuity there is about 0.3 percentage points. Now the fuzziness comes from two things, and there's a technical appendix on this. I can discuss it at more length if anyone's interested, but first, there is some noncompliance, and we looked at the data to figure out how much of this is noncompliance and how much of it is due to measurement error, and the fact that we really do need to estimate this cutoff for each school, because we have to estimate the number of students in the classroom, the number of non-gifted spaces in the classroom. And it looks like there's, initially in the first year, there's incomplete compliance, and over these 4 years, the compliance with the district rule got better. So we know that this is partly due to actual non-compliance with the district formula. But it's also partly due to measurement error, and the fact, and sort of the combination of not being able to measure precisely, first of all, matching students to classrooms. This is actually trickier than it sounds. We have to do this by matching students to teachers. And in any school, there's always students coming in and out of the school. There are students that come in and out of the classroom, maybe transfer in and out of the classroom. There are students that don't have third grade scores. They may be coming from outside of the district, so they have a rank, but we don't see their score. So for all of these reasons, we end up with a noisy measure of n, the number of free seats in the classroom. And we use an iterative procedure to try to, we start with that estimate, the measured number of extra seats in the classroom, and then we adjust that a bit. The reason this is important is because if the first stage is measured with error, then our two-stage least squares estimates may be slightly biased. And so we try to estimate the measurement error. We have some schools where we think there's very little measurement error, and we estimate that the measurement error in the first stage is about 15%. So when I show you two-stage least squared results, they're probably about 15% too large. So they should be scaled down just a bit. So here are the reduced form relationships for the fourth grade standardized test scores. In reading and math, we see significant discontinuities. And both, for fourth grade, we have writing scores as well. We don't see any effect on writing. And then we also look at the gain scores in reading and math using the difference between third and fourth grade. We don't have gain scores in writing because there's no writing test in third grade. But we see similar discontinuities regardless of whether we look at the level of the gain scores, which is what the discontinuity is slightly larger in math when we look at the gain scores. But they should be the same if the RD is valid. This negative slope in the gain scores is just regression to the mean. The size of the effects is, on average, about 0.09 standard deviation. That's very consistent for the reading, regardless of the model. For math, it's between 0.07 and 0.10, slightly larger when we use the gain score. All right, so this is the average effect. Just some robustness tests. Those are based on local linear models using a bandwidth of 10 points on either side of the cutoff. We can vary the bandwidth between 5 and 15. The estimates are pretty stable. So here we're just, the estimate is a function of the bandwidth. In reading and math, it's almost always statistically significant, pretty stable. In writing, it's universally pretty close to 0. So now moving on to the heterogeneity analysis. This table shows a couple of things. First, we do formal tests for discontinuities in the baseline scores just to make sure we're not, there's not some problem with attrition or the sample in the RD analysis. The first stage results, we want to look at those and see if they differ across groups. They do differ a little across groups, but it's also true that the measurement error is a bit worse in the poorer schools because there's more turnover in the poorer schools. But it's not going to matter too much. Our main results are going to be there are big effects for Black and Hispanic students, if anything, negative effects for whites. So we report here the two-stage least squares estimates just to get a sense of the magnitude of the effects. For the full sample, if we scale up, we multiply by 3, we get effect sizes of about 0.3 standard deviations on average. When we look separately for whites and minorities, Blacks and Hispanics, we see that these are entirely driven by Black and Hispanic students. And these effects are pretty big, even if we subtract the 15%. It's about 0.5 to 0.6 standard deviations for both reading and math. If anything, they're slightly negative for whites. If we look separately for Blacks and Hispanics, we don't find significant differences between these two groups. Yeah.
So do you think those differences are driven by some of the student level thing or a school level mechanism?
Yeah.
Is it that the schools where Black and Hispanics go, this matters more, or there's something about
Well,
maybe poorer students or something?
that's a good question. So we try to, good segue, look for just Blacks and Hispanics, compare free lunch eligible to non-eligible, and we find similar effects regardless of their free lunch eligibility. So it doesn't, I mean, these two rates is highly correlated with free lunch eligibility, but it appears that there are effects regardless. When we split the sample into different schools, the point estimates are larger for the schools with fewer gifted students, and that's where most of the minority students are. But we still see significant effects in the other schools. Now, there aren't many minorities in the really high gifted schools, but to the extent we can tell, it's not mainly about the schools. We also look at, we split the sample into boys and girls. And there is some suggestive evidence that the effects are larger for boys, although they're still there for girls. And here's just some visual confirmation of the heterogeneity results. Mm-hmm.
Can I actually say a little bit about the standard error construction? Because my understanding here is the forcing variable is coarsened and can only take on one of 20 discrete values. So I'm guessing you're probably clustering.
We're clustering by school. We can do the Cardley thing too, and I don't know. Dave said we should do cluster by schools. He says that's overused. The worrying about that, it actually doesn't make much difference. Clustering on the rank, but yeah, all the standard errors are clustered by school. So this is I have the reading and math fourth grade scores for whites. We see no evidence of discontinuity, and the discontinuity is pretty clear, especially for reading among minorities. So do these effects persist beyond fourth grade? For all these cohorts, we have both fifth grade and sixth grade outcomes. Shows the results for fifth grade outcomes for the full sample for whites and for minorities. And we see the same pattern of heterogeneity between whites, Blacks, and Hispanics. It says the effect sizes here are slightly smaller in fifth grade than they are in fourth grade. One thing that may be going on here is that students are assigned in fourth grade based on their third grade scores. And then when they get to fifth grade, they're reassigned based on their fourth grade scores. So some of the students who are below the cutoff to the fourth grade class are going to get in the fifth grade class. There's going to be some contamination there, if you will. And if there's an effect of being in the fifth grade GHA class, then you might expect that this is the RD for being in the classroom in fourth grade. We're trying to see if there's a persistent effect of fifth grade. So we do find a persistent effect, but it's not always significant. It is larger for blacks and Hispanics. Now, when we get to 6th grade, they do have some tracking, but it's a different system. And so we might see the effects to reappear if there's a long-run effect of being in the classroom in 4th grade. And we do see significant effects for blacks and Hispanics on 6th grade reading and math. Just again, to come back to the visual evidence for minorities, just to confirm these long-run effects aren't contaminated by some sort of differential attrition, and to sort of kind of see them all for the same sample. These pictures are all based on the sample of minorities that stay in the district through 6th grade. We see the first stage here. The NNet scores for those for whom we have the data are still smooth through the cutoff, which is reassuring. The 3rd grade scores are still smooth through the cutoff. We see a big discontinuity in 4th grade, a smaller one in 5th grade, and then it reemerges a little bit bigger again in 6th grade. So, question of what's the mechanism for the long-run effects in particular. So I mentioned students are reassigned in 5th grade, and then there's also some tracking in 6th grade. So if you have higher achievement scores in 4th grade, there's going to be some mechanical effect on your placement in later grades. So we tried to see, is that big enough to explain all the effects? So in other words, is there some learning begets learning, and doing better in 4th grade helps you learn better in 5th grade? Or is it simply a matter of just continuing to be placed in the higher tracks? And we find small but significant effects on the probability of being placed in a 5th grade GHA classroom. Again, as you'd expect, they're entirely driven by blacks and Hispanics. In 6th grade, we can determine which students are in the advanced math track. It's harder to measure for reading, so we just look at math. And again, we see that there's a significant probability of being in the advanced math track at the discontinuity for blacks and Hispanics. However, if we assume that the impact of being in the 5th grade GHA class is the same as the impact of being in the 4th grade GHA class, and then we ask, is this jump in the probability of being in the 5th grade class large enough to explain the 5th grade outcomes? It's not. So these estimates are too small, essentially, to suggest that the entire 5th grade discontinuity is explained by a higher probability of being in the 5th grade classroom. So the results really suggest that there's some persistence in the learning effect in 4th grade, or in whatever it is that happens in 4th grade, which we can come back to. So next, we want to look and ask, well, is the RD valid in terms of the students below the cutoff being a good counterfactual for the outcomes in the absence of a GHA classroom? So here, again, we exploit the fact that schools have to have at least one gifted student to offer a classroom. And in these 4 cohorts, about half of elementary schools had between 0 and 4 gifted students in 4th grade. We're going to focus on these just to avoid really big differences in comparability across schools. And then use the presence of a gifted student in your 4th grade school cohort as an instrument for being in a GHA classroom. Because schools that have more gifted students are going to be different in some ways, so we adjust for this by estimating a trend in outcomes in the number of gifted students in the school cohort. We also adjust for a bunch of things. We use gain scores, and then we also estimate models with school fixed effects, just identified enough schools that have 1 or 0 gifted students identified in alternating years. And we also estimate models that restrict the sample to just schools that have 0 or 1 gifted students. So we do a bunch of different things. I'll just show you some pictures that sort of summarize this research design first. These top 2 panels show kind of the first stage. This is the number of 4th graders in this cohort. We estimate a linear model with the break at 0. So you can sort of think about this as an RD design where the discontinuity is at 0 for both students, the top ranked students, students ranked 1 to 20 in the class, and students are ranked lower, if there's no gifted student in your cohort, there's no probability of being in a GHA classroom. The probability of being in a GHA classroom jumps when you have one gifted student in your cohort, jumps to about 40% for the top ranked students. This is a much smaller jump for the lower ranked students. Then if we look at outcomes here, for the top ranked students, the average reading and math gain score is much higher for students who have a gifted fourth grader in their cohort than those who are in a school with no gifted fourth graders. But there's no significant difference among students who are ranked like 20 to 44. So these are students who are not likely to be in the GHA classroom if there is one. So essentially this suggests that there's no net spillover effect on these students from the creation of a GHA classroom.
So if you, just make sure I've been logic, if you thought the RD effect you should give it all by harm to the kids just below the threshold, you would have seen
Yeah,
the red dot.
we would have seen a discontinuity here, but not, or perhaps not there. It could have been all driven by harm to the lower ranked students.
Right. Would the red dot be above?
Above it, it would be above it, yes, it would be above it, right. Right, yep. So here, the estimates, they're pretty robust, the different models. We can control for school cohort characteristics. We can add school fixed effects. They get noisier, of course, but the point estimates are pretty similar. And then if we restrict the sample to schools that have just 0 or 1 gifted students, we again get pretty similar estimates here. Now, to boost precision, we are combining reading and math scores. It gets harder when we separate those out. So these are the impacts on students who are ranked 1 to 20 in the school cohort. Then if we look at students who are ranked 25 to 44 in the school cohort, the estimates are all pretty close to 0. We can do more. Another advantage of this approach is we can get away from the cutoff. So the RD design just identifies effects for the marginal student. So if we want to know, well, what about the students who are kind of at the top of the class? Are they benefiting? And we lose a little bit of precision here, but we divide those top 20 students into 4 groups, 1 through 5, 6 through 10, and so forth. And then we estimate the 2-stage least squares. The first stages are going to be different across these groups. But the IV estimates suggest that there are gains to these top students, but they are substantially smaller. So the students who are in our RD sample are the students within 10 points of the cutoff. They're the ones who are mainly benefiting. And the higher ranked students aren't benefiting as much per this design. Now, another nice thing about this is we have sort of another validation for the RD estimates. And one thing to keep in mind is that this sample is the sample of schools where most of the minorities are concentrated. So this design also identifies the effect mainly for Black and Hispanic students, so we can sort of compare this to the effect, to the RD effect that we find. And yeah, this is the estimate we should compare to the RD effect. It's actually in the ballpark. It's actually quite similar to the effects we find for Blacks and Hispanics in the RD model. So this is sort of just additional validation for the RD estimates. Now we can also look all the way down, sort of take all the students who are ranked 20 on. Schools differ in size, so if we want to look for evidence of spillover effects anywhere else in the distribution, we do this by dividing the rest of students into quintiles and estimating separate models for each quintile. And for the most part, we find estimates that are pretty close to 0 for all of these groups. So there's really no evidence of a net spillover effect on any other group. Another thing we can do is go back to the RD design. Now, this is just a sort of a global RD model where we use a quadratic and expand the bandwidth a lot, just to see if we see any evidence that the discontinuity is here for the lower ranked students and sort of disappears at the top. This red line here is predicted scores using a quadratic model and all the students below the cutoff. The blue line is the observed scores. And indeed, for the full sample, we see this discontinuity here that sort of fades out as you get up into the top of the distribution. And if we look just at minorities, we see an even more dramatic pattern. So we wouldn't want to rely just on this. 'Cause a lot of functional form assumptions here, but it certainly seems consistent with the results I just showed you. So the final question, again, maybe the most important question, but the hardest question to get at, is what's the mechanism? So I didn't start with this because at this point now, I'm going to argue that I've ruled out a lot of the mechanisms you might think about. There are a lot of ways that a tracking program could affect students, and could affect students not only who are placed in the higher track, but students who are placed in the lower track. And in part, we've ruled out a lot of these explanations, or we think they're probably unlikely, because we find effects mainly for minorities, and we really don't find any effects for white students. So we're really looking for a mechanism that affects minorities differentially. But that said, like, what could the possible mechanisms be? Well, one, you think of tracking as allowing students to, teachers to better target their instruction to the level of the classroom. And as an experimental paper by field experimenting in Kenya by DeFloy, DePauw, and Kramer showed that this sort of tracking, dividing students into two classrooms, can benefit both higher and lower ability students. So in theory, it could benefit both. And we wouldn't have found an RD in that case. The students in the higher track could benefit from having higher achieving peers. So if the targeting has a positive effect on the students who are left in the regular classroom, the direct effective peer characteristics would have a negative effect on students who are left in the regular classroom because they're losing some of their peers. In our case, you might think that neither of these things is going to have a big effect on the students left in the regular classroom, because only about 20% of each school is separated into the gifted high achieving classroom. So students on average are losing about 20% of their peers. These two possible mechanisms could cancel each other out, but we've found that on net there's no spillover effect on the students in the regular classroom. There could also be rank effects, which would also pose problems for interpreting the RD. The marginal GHA students could suffer from some mismatch or invidious comparisons, thinking now that they're at the bottom of the class rather than at the top of the class. There could also be a top of the class effect for the students who are now at the top of the regular classroom. But the between school analysis really suggests that at least on net, none of this is going on. A final explanation is that they could assign better teachers to the GHA classroom. So again, it would have to be the case that this differentially affects minorities to explain our results, but it is possible. So how can we assess peer and teacher characteristics? Well, we can assess direct peer characteristics, direct peer effects, by looking at the characteristics of the peers in the classroom. We don't want to directly control for peer characteristics in the RD because we have a fuzzy RD. There's a lot of noncompliance. So peer characteristics are going to be correlated with complier status being in the GHA classroom, and that would bias the estimates of the effect of peer characteristics on outcomes. So what we do is we try to estimate the peer effects, or the effects of peer characteristics, using a value-added approach. We take all the data we have going back to 2004, estimate models with school fixed effects. The outcome is the gain scores in reading and math. And we put in a bunch of peer classroom characteristics, including average lag test scores, the variation in lag test scores, the fraction of students who are suspended, the fraction female, interaction of gender and race, the fraction of minority male. And then we also estimate value-added models for teacher quality. So we can look at the effects of fixed teacher quality to see if the GHA classrooms are assigned better quality teachers, at least as measured by teacher value-added. Now, peer characteristics and teacher quality can't be the explanation unless there are significant discontinuities in these characteristics. I don't have a clock here, so I know I'm going to mess up. I have 10 minutes. I hope I didn't just mess up that. I probably did. All right. But as you'd expect, there are significant discontinuities in the peer characteristics. Peer average reading and math scores have a big jump. The GHA classrooms have less variability in the classroom. Fewer kids who are suspended in 3rd grade. There are more girls in the gifted high achieving classrooms. Fewer minorities. So all of these peer characteristics are potentially explanations if they differentially affect minorities. When we look at the relationship between rank from the cutoff and teacher value added, we don't see any evidence of a discontinuity. So this suggests that, again, at least along this measure, there's no assignment of better teachers to these classrooms. Now, that's not to say that it doesn't have to do with the teacher. The teacher might improve over time, or the teachers might get better at teaching these particular students. But to the extent we can measure it, we don't see any evidence of a teacher effect. Yeah.
Is there any kind of standardized curriculum or a different instructional model? I mean, is this really just tracking and they said, hey, now you have a class of students who are higher for achievement, or was there some explicit sort of gifted and talented sort of curricular model?
Definitely not a difference in the curriculum. So it's the exact same textbook. They have to cover the same curriculum. They're not allowed to accelerate. What they're allowed to do is enrich, go at a faster pace, and supplement. And so the teacher interviews suggest that there's no standard way of doing this, that it really depends on the teacher, and it varies a lot across schools even. Only in a couple schools did the teachers we interviewed say that they had access to all the supplementary material they asked for. In most of the schools, they said they just share stuff that they find online, they use their books from home, that there's really no instruction that they do. To the extent that they're required to do anything different, it's based on these individual education plans, but they're only for the gifted students. So for the gifted students, again, a lot of them suggest, we hired a gifted specialist to read through some of these educational plans, which actually the staff don't even have time to do, to sort of see how well the schools are complying with these education plans that they write up. And she said a lot of them weren't even written up, they weren't even in compliance with the way they're supposed to be done. So the evidence suggests that there's really not a lot different going on. The one consistent thing we heard is the teachers said that there's more flexibility. They don't have to do as much drilling on the standardized tests. They don't have to worry as much about their value-added scores. And they have more time to do other things because they can go at a faster pace. So in fact, going back to when we found no effects of the marginal student of being identified as gifted, a lot of the teachers told us, well, of course, you wouldn't expect to find effects on the standardized tests because we don't focus on those. We do other stuff. We do enrichment. And so that might, in these lower income schools, they really do have the room to gain on the standardized tests. It's not just all about enrichment. So I think a very strong impression is that in these schools, it's just a tracking program. They just put the kids in a separate classroom, and there might be some endogenous peer effects or teacher expectations that change, and that's really what we think is going on. But right.
Class might be much lower in the schools with lots of Black Hispanic students. So that is this driven by, is it really heterogeneity in terms of prior performance rather than heterogeneity by race per se?
It is highly correlated with, yes. So in fact, I think that's one of the things that's correlated with race that I think does matter, that they are lower achieving. And in fact, so moving on, we don't find direct peer effects, but we do think that there's something different about these classrooms that perhaps changes teacher expectations or endogenous peer pressure. And so the flip side of that would be that in the regular classrooms, minority students face obstacles. They're underachieving relative to their potential, and then they do have lower achievement. In fact, the evidence of this, so how would we know if minority students are underachieving relative to what they could be? And here we use the cognitive ability scores from second grade from the screening test, and we estimate achievement gaps by race. And as we all know, they're big achievement gaps by race. We don't condition on anything. But then even when we control for even for flexible model of the nonverbal ability scores, we see big achievement gaps conditional on those. We can put in free lunch status and school fixed effects, and we still see big achievement gaps. But so one interpretation is that, yes, these students do have lower scores conditional on their ability. Now, they're still within their school. They're still, ranked relative to the whites and everyone else in their school. But why is it that even within the same school, minorities are benefiting and whites aren't? One explanation could be that they're underachieving. This is consistent with what we're finding in the universal screening results, that it's the relatively low achievers with high IQ that are overlooked. Perhaps the teachers aren't recognizing their ability. And once they're in the GHA classroom, expectations change. Possibly negative peer pressure goes away. There are some other studies that find evidence consistent with negative peer pressure for minorities. The sort of acting white hypothesis that minorities face pressure not to perform well in school. So we suggest that our evidence is consistent with some combination of these two explanations. Interestingly, this sort of conditional gap in achievement is roughly similar to the effect of being in the GHA classroom. So the impact of getting into the GHA classroom for minorities is big enough to close that conditional achievement gap between blacks and whites. And then finally, we might think if there's an endogenous peer effect, that it would also change student behavior. And we have two measures of student behavior. One is skipping school, so we look at unexcused absences, and then we can also look at the number of times they're suspended. We look over grades 4 through 6, just to boost precision. And we look at the probability of having at least one unexcused absence or being suspended at least one time. Again, we see discontinuities in the full sample, but they're entirely driven by Black and Hispanic students. So we see evidence that both of those behaviors change for the marginal students in the GHA classroom. So in conclusion, this de facto tracking program for high-achieving students broadened participation in the gifted program, essentially. So they weren't officially gifted. It had large effects on the high-achieving minority students, and the impact was roughly large enough to close this conditional achievement gap.